This is a quick demo of a prototype I put together demonstrating how to create a order book using the OrbitDB. Let me pull up the OrbitDB GitHub page. So OrbitDB runs on top of IPFS, so it's a peer-to-peer database, which is a pretty sweet idea. And it takes different data types. In this prototype, I'm just using the key value pair. That's all I needed to create an order book. So the way a key value pair works is you have a key, which is typically a string, and that leads you to a value, which can be conceptualized as another string, but it doesn't have to be a string. It could be anything. It could be an array. It could be a JSON blob. And in fact, that's how I'm doing it. The database I implemented is very small, just a few key value pairs, and every value is an array of objects. And I'll show you a little bit about what that means. So this is the prototype demo right here. I put it up on ipfs.p2pvps.net. And this is also an IPFS node. If you use IPFS and you want to add another node to your swarm, feel free to add that on there. So what this is doing is it's loading IPFS using the JS IPFS library, so it's actually running an IPFS node right in the browser. And then once it does that, it loads this OrbitDB that it's created. Now, when you go to this site, a couple caveats is it's buggy. If you definitely want to open your console, your web console, if you use Firefox or Chrome, it doesn't matter. They all have the console. Even Safari has the console. I strongly recommend not viewing this in Safari. I have no idea how that will turn out. But if you see red down here, just hit Control R or hit this refresh button. Refresh. Like, all good things come from refreshing. And IPFS throws out a lot of weird errors. It can error out for a lot of weird reasons. This is also a prototype, so it's pretty buggy. So chances of you coming across bugs pretty high. So again, if you see red, just refresh your browser and start over. Of course, the problem with that is that I want to walk you through it. So let's just do a demo here of what that will look like, because it's kind of time consuming to wait for it to load. And it's just the nature of a P2P, of a peer-to-peer application. So here's the page loading. It's getting the address of the database from the server. It created an IPFS node in the browser, and this is our peer address here. It's telling us IPF is ready. Now it's trying to retrieve the see, there's an error right there. Go ahead and just hit continue. Yeah, okay, so in fact, there's some red, so I'm just going to reload. But what you'll notice if you do this a few times is there's this waiting ... It takes it a little while to load the database, download the database and load it. I'm not exactly sure why. It seems pretty consistent across peers. So that's what I mean when I say so there it went ahead and it loaded at that time. Database is ready. So in order to implement this, we'll need some better error handling that is implemented in this simple prototype. But so let me walk you through here. This has just got some links to OrbitDB and IPFS, and here's a link to the GitHub repository that contains the code. And this is really just a widget. It's simulating. It's a random walk price feed, and so it's simulating a price feed. And that's really not important for the order book at all. I just created this to give the user something to look at. I had originally, my original ambition was to kind of turn this into a game where people could buy and sell and trade and try and like sell their shit coin and buy a gold coin, and then whoever ends up with the gold coin after a certain, the most gold coins. But that was a little too ambitious. But all this is doing is this. So there's a centralized component to this, and there's a decentralized component to it. And the centralized component is very small. The server itself is giving us this price feed, and that's centralized, and that's pretty normal. In terms of like a real world, you'd have a centralized source of truth for a price. And the only other thing that the server is giving us is this initial database address. We only need this once, and then we don't need it anymore. And that's just to allow new peers to sync up to the existing order book that all the other peers are using. And those are the only things coming from the server. The actual order book lives in the OrbitDB and is fully decentralized. And I'm going to give you a demo here. So here's the basic controls. It loads like this. It comes up with the default handle of handle. Feel free to change this. So I'm going to change this to Chris, and I'm going to put in some orders here. I'm going to do let's see. I want to buy at 1,000. I'll buy 100 units at a price of 1,000, and I'll buy another 100. Let's see, 50 units at 1,100. So I'm going to add these. And you can see here that I have these cancel buttons, so I can actually cancel the order if I want. Oops, I think I accidentally canceled all my orders. So over here in this tab, you can see I'm getting these messages that replicated with the peer. So I have it open in 2 tabs, and it just that was it. This tab detecting the changes I made in this tab. I'm just going to change my name to Chris again and add those orders back in. 1,000 at 100 and 1,100 at 50. See if this tab caught up. Yeah, so this tab caught up. It detected those changes in the database and replicated them and put them in there. In fact, I'm just going to change this handle to Steve. And he's going to put in a buy order right in the middle at 1150 and do a quantity of 25. There we go. Cool. And then this tab picked that up, and then here I'm going to go into this. This is a Linux VM that I'm running, and this has been running the whole time. So this is a totally separate computer as far as the other computers are concerned. And I'm going to put in another buy order here. Oh, it looks like I need to refresh. There we go. Connecting. And this is actually running a local copy. So one of the things I'm hoping to do is that you can load this app from this URL, or what I'm going to do is I've created all the code so that it's statically compiled, and so you should just be able to check this app out from IPFS and load it on your local computer. So this is an example of that. This is running the index.html file locally, and all the JavaScript files are packaged together with it, so you can run everything as like a sort of a blob. You can just download a blob and open this in a web browser, and everything will work. You don't actually need to access an internet-based server. So here we go. We got all these 2 tabs in that virtual machine, and they're all synced up, sharing the database to one another. So let me show you the order book functionality. So I got my buy orders. My handle's still Chris here. I got Steve over there. And so I'm going to switch this to sell. And a match happens when the buy is greater than the sell. That's when a buyer and a seller can get matched up. So I'm going to say, what's the top? So 1100 is the top price. So I'm going to say 1099. I'm going to sell 10 units. So this quantity 50 should go down to 40. Oh, let's see. So I added it. What did I do wrong here? Oh, I guess maybe the cell needs to be higher. Let's try 1101 and 10 units there. Oh, because I'm the same user. That's why. You can't buy from yourself. That doesn't make any sense. I'm just gonna refresh this. Okay, this one's looking good. Okay, so I'm gonna have Steve buy at 1009. I'm gonna buy 10 units at 1,000 and I guess 99. $1,099. Oh, that was a buy order. Cancel that. Okay, obviously that cancel button's a little buggy. I gotta do that. So now I'm gonna put in a sell order. There, okay, I've been matched. I've been matched with Chris. And there you can see the quantity was updated. 10 was subtracted from the original 50. And if I go back here, I don't think this was loaded in time. And so let's see here. So now if I change my handle back to Chris. Linux is selling at 900, so if I go 899, I'm going to go 10. We'll see this 123 go to, what would that be? 113. Oh, shoot. Again, that was a buy order. Need to make that a sell order. I was matched with Linux, and bam. Okay, so that order went down to 113. Then I can go over here to Linux, and they get the notice that they've been matched up. And again, I don't know if you just caught that, but the database refreshed. Okay, so there's a sell order. Sell is selected. I'm going to buy at 1050 and 10 units. So that should trigger this one. So this should go down to 30. You've been matched with Chris. And then that just went down to 30. And here, my handle Chris got the notice. So that's it. That's basically the gist. So let me walk you through the code so you can understand a little bit better of the business logic, how it's going. Again, you can click on this link and it will take you to the repository. And there's a front end folder and a price server, which is the server side. The server is really not very interesting. It's an Express application, and it's coming up, and it is creating a local IPFS node, which is interesting, and which needs to happen in order to initially create the database. But then after that database is initially created and seeded to the peers, that's no longer needed. So the server really just bootstraps the creation of the database. But it also it has these two API endpoints, and that's all it does is it feeds the price. You can request the local price. Let me show you what that looks like. IPFS/price. And that just gives me the latest price. So all this application's doing here is it's every 2 seconds, it's just asking for the price. It's just pinging this, and you can see if I refresh, I'll get a new price. So what the server's programmed to do is it's a random walk, so it's just changing the price by 0.5% every second, and just to kind of keep it. And then this chart updates every 2 seconds. And then the second API endpoint is order book, and this is just the IPFS address of the database. And so it's not actually seeding the database, it's just seeding the address to the database, and then that peer goes to the IPFS network and downloads the database. And so that's all there is to that. let's go check out the front end, because that's where the magic happens. And there's really, these are all just, like I said, static libraries. So there's jQuery, this is the IPFS library, this is Bootstrap, this is a chart library that does that price chart. There's the only two really important libraries are here. The price chart library just has to do with the price chart, which I hope by now I've emphasized that it really has nothing to do with the functionality of the order book. All the important stuff is here in this order book. So let me walk you through here. Reset table resets that resets this table to the way it originally was before the database was loaded. That's just to get it to a known state. It then calls show orders, and that grabs the data from the database and populates that table with the data from the database. That's all that's going on there. There's this cancel order, which is triggered when you hit the cancel button, and that's obviously a little buggy. And oh, and by the way, if I wasn't clear here, to change your handle, you just, whatever, type it in there and then hit tab, and that's your new handle. It'll automatically happen. And if your handle's already in the table, you'll see those cancel buttons pop up. And then the add order. This is one of the more important functions. So it just grabs the data that you put in here, validates it, and then it creates this object, this my order object, which has by cell, which is true for buy, false for sell, the price, the quantity, and the handle of the person entering the order. And then it stores it in the database. And let me just show you a little bit more what that looks like. So I mentioned before that it's a key value pair. And so the most important key that I created is peers. And this is a list of all the peers in the database. So right now there's 5. So the key and the value. The key is peers. The value is the array. And so then I can go db.get, and in here I'm going to put in the key Chris, and I'm going to get back the value, which is an array, or an array of objects. And so here is, and those objects are order, what I'm calling order objects. They represent an order. So it has the buy sell, whether it's a buy or sell. So this is a buy because it's true. The peer is Chris, the price is 1,000, and the quantity is 100. So that just reflects what you see here in the table. So it's very simple, and by keeping it very simple, it's very fast. And let's see, where was I? It was over here. So that's all it's doing, is it's adding the new order to the database. It resets the table and then repopulates the table to refresh the DOM and show the latest updates to the table. And then it calls match orders to see if there are any orders that match the new order. And matched orders, it navigates the database and attempts to match buy sell orders. And the way it does that is it's just kind of brute force right now. There's probably a more elegant way to do that, but it goes through. There's this logic for buy orders, and then if you scroll down, there's this chunk of sell orders. They're almost identical, except the logic's reversed. And it just loops through, basically goes through every order in the database, which even though it's kind of a brute force way to do it, it's pretty fast because the database is very small and very nimble, which it needs to be in order to be a peer-to-peer database. And then if there's a match, it will throw up this alert that we saw, and it will call TradeDB, and that's where the actual trade happens, where the database is actually, the trade occurs and the database is updated to reflect the state of the trade. And so you pass in the sell order and the buy order once you've determined a match, and then it walks through, and there's basically 3 cases. The first case is when the buy and the sell quantities are equal. We can just delete both orders from the database. That's what's going on right here. If the sell quantity is less than the buy quantity, then we sell all, and we remove that order from the database, and then subtract the quantity from the buy order and update that order in the database. And then the sell is the opposite. if the buy is greater than the sell, then you buy everything and delete that order from the database, and then you update the sell order with the difference in the quantity. And that's really all there is to it. This validate DB function just makes sure that the database, everything's in order, does error checking before you start interacting with it. Let's see, there is the index file, or the actual web page that's got some JavaScript down here. This is where it's actually calling the database. This document ready, this is called when the page is finished loading, so it won't run the code until everything's loaded that it's depending on. This just sets up that price chart. This load IPF function is what's really important. Here it creates a new IPFS instance, and when that's ready, when the IPFS is ready, it creates a new instance of the database, opens the database, so that's where it's actually going out and retrieving it from IPFS. When it's ready, we'll get this little database is ready signal. Then it will load the local copy of the database that it already has, and then it will immediately go out and try and update that local copy. And then it will try and match the orders. And then when a peer updates the database, we'll get a signal, and this replicated event will occur. And that's this is what we were seeing in the console here. The database was just replicated, so then it resets the table, refreshes with the new data, and tries to match the orders. So each peer is doing this on their own, independently, and it's all syncing up, and it's pretty amazing technology that allows this all to happen. I don't fully understand it, but it's pretty cool that I get to play with it. Trying to see if there's anything else. This get DB address, this is what it's calling out to the server to get the IPFS address of the database. This get price just goes and gets the latest price from the server. So that's pretty much the gist of it. Let me see if I went through. So I talked about bringing up the console log. I talked about the price is centralized, but the order book is decentralized. I showed you how to get to the GitHub repo. I talked about how to add orders to the database and sort of how that logic works and how the logic of matching orders work. There is, so you can have multiple. So there's bugs. If you play with this, like I think I showed the cancel bug. I can also add orders. Multiple orders at the same price. So I already have one for 1100. So if I can add another one for 1100, which is kind of weird. I haven't added any logic in to do that. It's pretty simple. I'd kind of like to fix some of these bugs and then see how it behaves with like lots of people using it. I think that would be pretty fun. But that's why I moved it to this server. Feel free to try it out. No guarantee it's going to work. If things start acting weird, again, you need to just open your console and refresh. Refreshing fixes everything. And if you see red, refresh. All right, enjoy.